In the last lesson, that is 47, we did simple microscope, compound microscope, and obtained the relationship for magnification for different cases. Now another type of optical instrument called telescopes, also called astronomical telescope. Uh, these telescopes are used for magnification of objects that are located at large distance. For example, stars, but appear small due to their large distance. So we need a telescope for that. There are two different cases. Now the case one, called the normal adjustment of the telescope. If the final image is formed at infinity, then that adjustment is called normal adjustment. Now look at, in the diagram you find two convex lenses. This is one convex lens, the center C1, optical center. This is another convex lens, optical center C2. This is large in size. Forget about these black lines. Now C1 is equal to optical center of the objective lens. This is called the objective lens because light from the object, which is very far off, fast falling on this lens. Therefore this is called the objective lens, or just called the objective. It has large aperture. The opening is more as compared to this. Large aperture and large focal length, which I represent as f0. What will be f0 from C1 to this point is your f0. This point is this capital F0, and this point is also capital Fe, which I will explain just now. Now C2 is optical center of the eye lens or the eyepiece, because we will be watching from this side. This is your eye. This is your eye. When you are watching, you are actually seeing the image of this distant object at infinity. Why it is at infinity? Let me explain. So C2 is the optical center of the eyepiece, or which is called eye lens, of small aperture. Its opening is less as compared to this, and its focal length is also small focal length, that is represented as Fe, from C2 to this point. Now therefore C1 F0, C1, this point is also F0, is the focal length of the objective lens in the direction of light. C2 Fe, C2, this point Fe is small Fe, that is focal length of the eyepiece. Now what's happening here is, since the object is far off, the rays of light are parallel. We know parallel rays meet at infinity. Parallel rays meet at the focus. If the lens is like this and the rays are parallel to the principal axis, then they meet at the point called the focus of the lens. Now if these rays are parallel but not parallel to the principal axis, means they are like this, they will meet at a point just below the focus, So that's what is happening here. These three rays are parallel but not parallel to the principal axis, so they meet at a point here. So this point will be just below the focus point, that is F0. So this point is F0, the focus of this. Now so A dash B dash is the image of the distant object due to refraction in the objective lens, due to refraction in this lens, and it is formed at F0 here. It is inverted. Now this eye lens is adjusted in such a way that, suppose this eye lens is here, as you bring it nearer, its focus, that is Fe, will move to this side. Suppose the focus of this, that is Fe, coincides with this point, then A dash B dash acts as an object for this lens, eye lens, at its focus. eyepiece is adjusted such that A dash B dash acts as an object for the eyepiece at the focus FE. Now, so a ray from here parallel to the principal axis will pass through the focus of this lens, and passing through the center, the optical center goes like that. These two rays, when produced backward, they come from infinity. So the final image is at infinity. Now let us analyze the expression for magnification. Let A dash C1 B dash is equal to alpha. If this is alpha, this will also be alpha, vertically opposite. A dash C2 B dash is equal to beta. So now look at, just I explained, the final image is at infinity because A dash B dash is at the focus of this lens. By adjusting this lens forward, A dash B dash is kept at the focus of this, therefore its image is at infinity. Let this angle is alpha, this angle is beta. Now the magnification is M is equal to tan beta by tan alpha, which was explained earlier in simple microscope and compound microscope. Now a tan beta, A dash B dash over C2 B dash, A dash B dash over C2 B dash. Now tan alpha, A dash B dash over C1 B dash, A dash B dash over C1 B dash. Now A dash B dash cancels. This comes to the numerator, C1 B dash over C2 B dash. Now let us see what is this and what is this from the diagram. Now if you look at the diagram, C1 B dash is the focal length of this lens called the objective lens, that is equal to FO in the direction of light, therefore positive FO. C2 B dash is the focal length of this lens opposite to the direction of light, that is minus FE. So the magnification is FO over minus FE, that is overall it is negative. Now the negative sign indicates the image is inverted. Now if you look at this is a fraction. If you increase this, magnification will increase. If you decrease this, magnification will also increase. Therefore to increase the magnification M, FO, that is in the numerator, should be more, and FE, it should be less.